Let's get started. So I want to talk about something that I care a lot about when it comes to designing software is to really create a lightweight software design. So I want to focus on a few things. You might be familiar with a number of these principles. In that case, it might give you an opportunity to dig a little deeper into these and maybe think about this a little bit more and then help your teams along the way as well. Best time to ask questions or make comments is anytime you have questions or comments. Please post them on the chat and I'll be delighted to respond to your questions or comments as soon as you post them. So let's get started. Well, we're going to talk about software design principles, and for about, give or take about 90 minutes from here, I'll dive into and talk about some principles and some of the perspectives that I've gained over time when it comes to these different principles. So what are really software design principles? Well, software design principles are really timeless. They've been around for quite a long time. They've been created over the years, but I find them to be extremely valuable on every single day when I develop software and when I work with teams of developers developing software as well. So this is a very important part of designing and developing software in general. But where do we really use them? Well, actually, in my observation, I normally look at design as two different things, a strategic design and a tactical design. A strategic design is a very high-level design initiative. This is where we are looking at a major aspect of the design, maybe components and parts that are communicating with each other. The tactical design, on the other hand, is where we are dealing with more fine-grained details, methods and classes and communication between classes, the signature of the methods, and so on. Well, oftentimes I tend to work with a strategic design initially, and those are not written on stone. It's something that I would normally evolve and change over time. However, the tactical design is where I validate the strategic design, I modify it, and then I evolve it, and then move the system from the conceptualization to implementation. And I often use automated test as a very important driving force when it comes to writing these tactical design into code. So I rely upon quite a bit of automated test. Well, I tend to use these design principles during automated testing quite often. In fact, one of the things I emphasize quite a bit is, to me, writing automated test is not a mechanical process. When they say write test and write minimum code and write test and write minimum code, I beg to differ. It's not a question of writing test and writing code and writing test and writing code. It's a question of writing a test and thinking through the test. And I often say the test cases you write kind of little whimper and draw your attention, and they ask you to ask the question, does this make sense? Is this a good design we are leading to? Do we need to modify a few things in here? Those are the questions you are often asking when you are creating these automated tests. So to me, it's more of a write a test, think about it, deliberate about it, rework your test, and then design the code to meet the test. So it's a very, very thoughtful process of writing the test. It's not a mechanical process at all for me. So I use these tests quite often during that phase of writing automated tests in development. So having said that, why do we really want to use these principles? Like I mentioned earlier, I find these principles to be rather timeless. We can use them so many times and we can still get the benefit of writing maintainable code, extensible code, and so on. And that's one of the reasons why I'm a huge fan of really writing these test cases. And we use this continuously throughout the development process. I use these design principles, like I said, when I write automated tests. I use these design principles as a communication tool with my team of developers when we are doing code reviews and pair programming. I cannot tell you how many times during code reviews, I'll tell my programmers, hey, let's keep this dry, or let's think of YAGNI, and so on. So this is something we do quite often, continuously when we are developing code. So we're going to talk about some design principles along the way, and I'll start with one of the very first principles, which is called the DRY principle, or don't repeat yourself. So the DRY principle, or don't repeat yourself, is a principle outlined by the pragmatic programmers. And the DRY principle really says that every piece of knowledge should have a single, unambiguous, authoritative source of representation. So that's basically what the DRY principle says, is that every piece of knowledge should have a single, unambiguous, authoritative source of representation. Now, the DRY principle outlined in pragmatic programmers is talking about removing duplication. And we see this quite often as developers in so many places. I remember one day a developer telling me, we keep fixing the same bug over and over and over. I said, oh my goodness, does somebody put the bug back into the code after you fix it? And he said, no, we have duplicated this code in so many places, we keep discovering them over and over and over. And I immediately asked the question, when you do find a duplicated code, you do remove this duplication, right? And he said, well, that's a great idea, we should do it. Well, of course, if we don't really remove the duplication, there is no end to it. So we need to be very aware of this kind of duplication. Well, sometimes we focus on duplication of code, and that can be quite misleading when it comes to identifying duplication in general. Case in point, I'll give you an example of a company that I worked with in the northwest part of the US, and they are into the shipping business. So they would have cargo put on a huge ship, and then of course they would send it out to different parts of the world. So their customers would typically log on to their website and create a shipment, if you will, and decide what they want to package and put into a particular shipment. Well, years ago, this application was written using Java in the back end and a plain simple HTML on the front end. Now, as you would expect, the users would come in and enter all the data for the shipment, and then they would click a submit button, and pun intended, they would get a boatload of errors that they have to deal with. And once they correct the errors, they click on the button, they will get more errors. This was getting very tiring for them. So what the company decided was that they would have a front end written using, of course, as you would expect, JavaScript and HTML. And then they decided in that particular case that their backend that they're going to create is going to be obviously what they had earlier, which is going to be predominantly written using Java and related framework. And you probably guess where this is going. So they decided to put the validation on the front end, but they also decided to create the validation on the back end as well in their particular application. And because of this, now there was code written using JavaScript for validation and code written using Java for validation as well. And that exists on both ends, if you will. And as months went on, they started seeing errors in the system. A validation will go through the front end, but will be rejected by the back end. Or the validation will be rejected by the front end, but if they bypass the front end and go to the back end using other APIs, that would go through, and this discrepancy started happening. Now, what was the problem here? The problem here is the code for validation was duplicated, if you will, and going back to the DRY principle, that piece of knowledge for validation was not in a single unambiguous authoritative source. It ended up in two different locations. We might argue, hey, one code is Java running in the back end, another code is JavaScript, which is running in the front end. So technically speaking, that's not duplication. But practically speaking, it really is duplication because that code exists on both sides, and that's the same information, same knowledge that's being duplicated. So the question is how to fix it. And I'm going to say there are two ways we could possibly fix it. The first way we could possibly fix it is to use something like Ajax. So you could do the validation on the server side, but it gives you an illusion of a client-side validation. As the user is entering the data, we could make a asynchronous call to the backend, push the partial data to the backend, perform the validation, and pull the response out. So the validation could be in the backend, but can be exercised incrementally from the front end. Another solution for this is to use code generation, where we could represent the validation on the back end, but we're not going to physically create the front end code for validation, but generate the front end validation code from the back end and push it to the client side. Well, so those are the two options I can think of. But thankfully, a few years ago, I was teaching a course on software design for a client in Norway, and in Oslo there was one fine gentleman, Adam, and he was in my course. And literally about 6 months later, Adam sent me an email saying, "Hey Venkat, I was in your course in Oslo. You were talking about the drive principle, and you gave this example of your client with this problem of shipping, and the code was duplicated. And I was in the class in the front row listening to you, and I felt really bad listening to you because I felt like you were talking about me. Even though I'm not working for the shipping company, what you said was exactly what we were doing in my company. So it really felt close to home. I really felt bad listening to you because that's exactly what we were doing." But then his email went on to say, "You gave me two options, one to use Ajax and another to use code generation. Well, I'm writing this email to you to let you know that there is a third option, and that's what we decided to use in my company." So I got really excited. I said, "Whoa, there's a third option. I want to learn about it." As it turned out, it was more of a 2.B option, if you will. And what they did was their code was predominantly a Java-based application, and all their code was in Java, but they decided to use Kotlin more recently. And what they did was they implemented, in this case, implemented the validation code using Kotlin. Now, why is this really exciting? So Kotlin, as you may know, is a multi paradigm, but more important, it is also a multi-platform language as well. So Kotlin is one of those languages that can be compiled, if you will. And in the case of Kotlin, you can use a compiler called Kotlin C-JVM to convert the Kotlin source code to Java bytecode. But you can also use the Kotlin JS compiler, and you can compile Kotlin to JavaScript as well. So what this team really did is they wrote the validation in Kotlin, and they compiled into Java bytecode to run on the server, and compiled it to JavaScript to run on the client side. So they literally employed the drive principle. But in this particular case, rather than writing a code generation tool, they very cleverly used Kotlin to perform that code generation, if you will. And so as a result, it worked really nicely for this particular team. So a drive principle is something we should really try to really address and see how we can actually remove the duplication as much as we can. But oftentimes, when people talk about the drive principle, they talk about duplication of code. But I want to emphasize that drive principle is not just about duplication of code. It's actually about duplication of effort, not just the duplication of code alone. So when we think of a duplication of effort, we think about it more broadly. So in other words, don't repeat what you do over and over and over, because that's inefficient, it's error prone, makes us less productive. We want to try to find a way to really automate that as much as we can. This is true for almost everything we do. For example, if you think about what we do every day as programmers, it is a bit shocking because there are so many things we do so manually that when we realize, we can find ways to automate. As an example, I cannot demo this here right now, unfortunately, because we are connected through the wireless network. But when I give this talk, usually in a company or a user group in person or in a conference, I usually demonstrate it. Now, if I go up to the top, you can see I have a Wi-Fi connection sitting right there, as you can see. Well, given that Wi-Fi connection, I realized one day years ago that I'm a programmer, but as a naive person, I would click on that link for the Wi-Fi, I would click on turn on, or I would click on it and click on turn off. This was really something I did without even realizing, until one day I realized, oh my goodness, I'm clicking on that button to turn on and turn off the Wi-Fi like a layman rather than being a programmer. And I got really angry at myself. And when I get angry, I like it because I quit doing the real work. Now I'm doing this meta work to find out a solution to some other perceived problem. And maybe about 15, 20 minutes of, Googling and searching later, I found actually there is a way to automate the turning on and turning off of the Wi-Fi using command line script. And once I did that, that is all I had to do. And since then, I'm working on my computer. I just hit a set of keyboard shortcut keys, and that will turn on that Wi-Fi or that turns off the Wi-Fi. But once I learned I can automate that, I went on to automate a lot of other things on my machine. For example, I found one day that I have a spreadsheet and I need to sort the spreadsheet every week and then remove certain columns from the spreadsheet that deals with privacy, then convert the spreadsheet to PDF, then load the spreadsheet on a remote server for publishing it. And again, I realized, oh my gosh, I do this every week. What a waste of time and effort. And I found a way to click one button and it will open the spreadsheet, remove the sensitive columns, sort based on the criteria that is necessary, produce a PDF file, remote log into the remote server, and push the PDF file and say, I am done, while I comfortably sit and sip a cup of coffee or go do something else. So you can find ways oftentimes to really automate stuff on your machine so that you don't have to manually be doing things over and over. And that can be really rewarding, if you will, in terms of what we generally need to do. And that's something we need to really find out a way for us to automate so that we don't have to be manually doing things. Once we realize it, we notice that there are so many things we often do manually. For example, manually deploying code is a violation of the DRY principle, if you think about it, right? Because manually you are deploying code over and over and over. Well, we can go towards a continuous delivery, but even before that, automating the delivery of the code is very critical for us to be able to get towards that kind of productivity. So that becomes very important. And I'm going to say manually verifying, and sometimes we use the word testing, if the code is still working, is a violation, if you will, a violation of the DRY principle once again. So this is why we don't want to be manually verifying the code over and over and over. We want to be able to automate that as well, because manual verification, manual testing is a violation of the DRY principle. So we can find so many things around us that we could automate so that we don't have to manually be doing things over and over, and that can really eliminate the drudgery of getting things done and can also lead us to a better productivity as well. So it's not just a duplication of code, it is a duplication of effort, and we want to keep an eye out on that along the way as much as we can. So I want to pause and see if there are any questions, comments, your own experiences. Maybe you have seen this before, or maybe you have experienced this in your own projects. Anything you want to share, I would be very delighted to hear your thoughts and hear your voices. I am not a big fan of just talking myself. And also keep in mind, with me seeing only myself, for all practical purposes, I could be alone talking right now with nobody ever listening. And that is one of the worst nightmares any speaker can have, is to wake up in the middle of the night and then just give a talk with nobody ever listening. And that's a feeling I get sometimes also with this video kind of setup, is is anyone at all on the other side. So I want to hear your thoughts, your questions. I want to actually get some interaction going, because after all, that's the whole point of meeting, is to actually have the meeting. So not you listening to a video. I'm actually connected live. So what are your thoughts? What are your questions, your comments? Have you seen this at work? Have you thought of other examples of violation of DRY? Are there cases where that may make sense, where it shouldn't make sense? You should have been seen my face when I heard the duplication of effort you're saying. That is actually so true quite a bit. We all, and it's more of an introspection, right? I keep doing this to myself quite often, is where we keep asking the question, what are we doing repeatedly that we could actually eliminate? So it's a lot more beyond the code. And what's really interesting also in this is, once we learn about removing these duplication of effort, we find more creative ways to remove those efforts over time. And there are so many things that I've actually automated. For example, I've automated business meeting reminders, for example, right? And this is one of the powers we have as programmers, is we can program our way out of situations. So I have things like, where I would get notification to remind me of a meeting, or to do certain things in a certain time, so I don't have to manually checking those things. Another question or a comment here is not a question, more of a comment, really. It's funny how much we hear the DRY principle repeated in talks. That's actually so true. And part of the reason is also because we still see it being told so many times, and yet we see so much duplication, right? In all fairness, I have seen so much duplication in my own code. I'm actually in denial that I've actually done that myself, in spite of me talking about it so many times. So there's a difference between knowing versus doing, and that's probably part of the reason is that we still need to be reminded of those so many times, because we are violating it. But in all fairness, right, one of the reasons to even emphasize that is, I'm working with quite a few companies right now, helping them towards better automation. And if you really think about it fundamentally, why am I working with them to improve automation? Well, that's because they had so much of duplicated effort. So it really goes beyond code itself. And that's a reason why we need continuous reminders about the DRY principle as well. And I think it's not the end of it. You're probably going to hear about it yet again moving in the future as well, whether we like it or not. So the next thing I want to talk about here is what's called the YAGNI principle. It's a controversial principle, but it's a principle I love. I like it a lot. And the YAGNI principle says you aren't going to need it. And I cannot tell you how many times I actually see this in my own experience. Oscar's comment here is, I've seen some weird attempts to reuse data transfer objects to avoid duplication of code, or the example when duplication is needed to avoid coupling. Oh, that's actually a really good question. I was waiting for that, Oscar's actually. One of the questions I was really hoping for somebody would ask is, should we follow DRY all the time? Or are there times we shouldn't follow the DRY principle also, right? So that's a very important question. I'll come to that in a minute. SK says, joke for a while, robots first replace programmers because they will automate own jobs. Well, I don't think it's going to happen in my lifetime, at least, SK, but maybe hopefully in the future. And you know what? I don't think that's actually such a bad thing. At least hopefully they will write fewer bugs. Let's hope so. So anyway, the question about DRY, I'll give you two examples where we should probably not use the DRY principle, or at least recognize it but not follow it. And I love these kinds of questions where we need to always talk about the pros and cons of it. So the one place where I wouldn't use DRY as much is in writing automated tests themselves. I don't go overboard to optimize my test cases. Sometimes I work with companies where I would look at a test case, I would be scratching my head. I'm like, I'm sorry, I don't have a clue what this test is doing, because they optimized it so much to remove duplication between tests that you don't even have a clue what the test is doing. So one of the key things is to not duplicate remove duplication in the test so much that we don't understand the purpose of the test anymore. So I'm perfectly okay with some duplication minimally in the case of test cases. That's one area where I don't go overboard to remove duplication. The other case where I often want to emphasize about the DRIVE principle is when it comes to microservices. When it comes to microservices, if your team is involved in creating two different microservices, they should avoid the urge to remove duplication between the two microservices. It's really important to have bounded context between microservices. The goal of microservices is not to reuse. The goal of microservices is isolation and autonomy and independent development and deployment. So you definitely don't want to remove the duplication between them so much so that you lost out on the other important criteria for microservices. So typically, I don't use the DRIVE principle as much when it comes to between microservices, but I would use the DRIVE principle within microservices, if you will. So those are the pros and cons, and thanks for that comment or question, Oscars, is that to really ask the question, maybe there are times when we shouldn't go overboard and use it. Definitely, I would say there are some situations like that we should consider, evaluate, and make the decision. So when it comes to the YAGNI principle, when I do code reviews, I often would just write a comment. And I would simply say, for example, YAGNI, and I would just leave it out there so that developers will look at the comment and maybe delete the code that's not needed. So what is the "you aren't going to need it" really mean? Well, we often write code to make the code maybe potentially extensible, or to handle a particular situation, or to implement a certain process in a certain way. And in doing so, we implement the code often that may not really be necessary. Excuse me. And when we do this, of course, unfortunately, we are writing a lot more code than necessary. And hands down, the code we don't write has the fewest bugs. So if we can avoid writing a piece of code, that is the best effort we can put in. So in that regard, I would even say, if you ask the question, what is the cost of doing something now versus the cost of doing something later? If the cost of doing something now is equal to, or 3 equals for you JavaScript programmers, if it is equal to the cost of doing it later, then I would say it's better to postpone that to a later time. If the cost of doing it now is greater than, let's say, the cost of doing it later, then this also is a good situation for postponing. On the other hand, if the cost of doing it now is less than the cost of doing it later, then I would ask the question, what is the probability that you really need it? If the probability of needing it is very high, then I would say do it now. On the other hand, if it is not really that high, I would say do it later and postpone it. Now, the question, of course, is why should we really postpone? And the answer to that question is, we can all agree that as time goes on, we learn a lot more about things over time. So we are smarter tomorrow than we are today, and we are smarter today compared to what we were yesterday. So with more information and relevance, we can write better code than without it. So if there's something we could postpone it, we should definitely postpone it and not implement it right now. And I can tell you how many times I see this with code when I review code. A developer may be handling a particular edge case, or a developer may be implementing a perceived extensibility when such extensibility will probably never happen in the code, and all that code is wasted code. But one of the problems is the more code we write, the harder it becomes to modify the code in the future. So minimalism is extremely important when it comes to this. This is one of the things we talk about in agile development, is what's called the last responsible moment. And it's different from postponing or procrastinating, where last responsible moment is if we postpone it anymore, it will end up actually being procrastination, but doing it any earlier would be too early. That's basically last responsible moment. But having said that, sometimes I work with programmers who are very apprehensive when it comes to using the YAGNI principle. And they often say, what if I really need it? What if I want to do extensibility later on? What can I do? And I often take this YAGNI principle and add a very small Y to the very end of this, which really stands for yet. So I often tell them, you aren't going to need it yet. And by doing so, I'm telling them, you can talk about this tomorrow and we can evaluate if we want to do it or not, but we don't need to really do it now. And maybe we'll postpone it long enough that we can actually release the product without ever having to implement that particular feature. So YAGNI principle, like I mentioned, is one of my favorite principles because I tend to really rely upon the YAGNI principle for deciding when to do something and when to postpone it. And if I don't fully understand a requirement or if it's not imminent, it is to really develop the courage to really postpone it. And in fact, I'm going to say programmers write as much code as restaurants serve food. Now, just to clarify, I'm not talking about restaurants everywhere. You know, I live here in the US, and in the US, restaurants are known to overfeed people. We get a lot of food when we go to restaurants. In fact, so much that when I travel to Europe, I'll feel starved sometimes in restaurants because they give you a portion, which is a right-sized portion, but that's very small for my, experience as an American who has who has eaten in restaurants here. But sometimes I'll go to restaurants and they would serve food, and I always like, my goodness, that's a lot of food. What are you trying to tell me? Is this my last meal? Why are you giving me so much food? In the same way, we should really have the courage to work in the opposite direction. An example of this I would never forget is I was coming back from an international trip, and I went to a really good restaurant, one that I like quite a bit. In Houston. I was not living in Houston at the time, but I knew this restaurant. So I had flown into Houston from international destination for doing some work that week. And when I went in there, I sat down and I was alone in the town. And the waiter came to me and said, what would you like to have? And I said, I would like to have this, this, and this. And in a very straight face, the waiter looked at me and said, excuse me, who else is joining you for lunch? And I said, why nobody else is joining for lunch? I'm alone here eating lunch by myself. And then he looked at me in a straight face and said, and all that food is just for you? And he was trying to scale me to see how small I am, and yet I was ordering so much food. And I said, yes. And he said, well, I will not serve you that much food. I got really upset. I said, what do you mean you won't serve me that much food? I have the right to order the food. And he said, let me make a deal with you. I said, I love deals. What do you have? And he said, you tell me what 2 items you want. I will bring them to you. And when you're done eating that, you just tell me you want the other 2. Not only will I bring those other 2 to you, but I'm not going to charge you for that. I said, I love the deal. Let's do it. And he served me the 2 items I asked for. I could barely finish them. And when he came around, I said, thanks for not only feeding me food, but putting sense into my mind as well, that I was ordering way too much food. But the point really is, that is a pure courage. The waiter could have shrugged the shoulders and said, heck, why do I care? You want that food, you ordered it, I'll serve you and take the money. But instead, he was very careful in thinking through and saying, I don't think you're going to be able to eat that food. And I think programmers should have a courage like that to talk to the customers and say, I don't think we need to implement that right now. We don't really understand why we need it yet, and we don't need to implement that particular feature. Let's postpone it until we get a better understanding. That courage is definitely lacking among programmers, and we definitely need some of that as well. So the YAGNI principle, I was reviewing a piece of code not too long ago, and I saw this programmer in a very genuine interest had a series of verification on the data that a function was receiving. And theoretically speaking, the range of data is wide, and practically speaking, nobody would send some of the data ranges based on the context. So I went to the programmer and said, you're doing all this validation. I appreciate what you're doing. That's great. Thank you. But on the other hand, all this validation, can you ever tell me when you would see this data? And the programmer said, almost never. Then why are you validating for a situation that may never happen, was the question. So we want to remove things that are not really needed. Let's see what Oscar says here. Grandma could use some of this food serving courage. Well, you know what? That is one place, Oscar, again, I would use the exception. I will never say no to my grandma's food. I really wish I had my grandma around still, honestly, but those are the best I would ever tell you. So grandmas are always exempt from this. They can pour all the love they want on their grandchildren. We should never obstruct that. So I would say that's one definite. You almost, I'm in tears when I read your words. It brings back fond memories of amazing people that I know who would pour their love by putting so much food and overfeeding. In fact, those are the fond memories. But commercially speaking, I would say restaurants and programmers should use the restraint, but grandmas and other beloved people are exempt from it. So YAGNI principle is something we can all use to reduce the amount of code we write on our project as much as we can. Switching gears, I'm going to talk a little bit about the single responsibility principle, but I will also tell you why I am not a fan of this principle at all. Don't get me wrong. I'm not saying that is not a good principle. I don't like the principle because it is really hard to use it properly, and I've seen a lot of people misusing that. And then I'll come back and talk about what that really means and how we could possibly benefit from maybe thinking about it a little bit differently. So the single responsibility principle really says that that a piece of code, whether a class, a function, a component, even a system, etc., right? So they all should have a single responsibility. So the question really is, what does it really mean, a single responsibility? It really is talking about high cohesion in general. So in other words, it simply says things that will change together or grouped together, right? So in other words, we want to minimize the frequency of change to a piece of code as much as we can. By bringing like things together, we are making the code a lot more cohesive. That's what it really means. The problem, though, is that we hardly can define the word responsibility correctly, right? So if you ask people, what does the word responsibility really means? That's where we have the difficulty oftentimes. Sometimes you probably have heard people say, right? If a function takes 2 or 3 parameters, then it violates, let's say, SRP. And I want to put a few question marks after it. Really, do we want to really measure single responsibility principle by just arbitrarily claiming that if it has 2 or 3 different parameters, it does? Artem says how to find balance, not splitting into small functional pieces into a system to become hectic. That's a beautiful question, Autumn, and I will talk about that in a few minutes. You are absolutely correct. And in fact, I have an answer for that because that is exactly the struggle I had as well. So we'll talk about that in just a few minutes. So this really brings back memories to one incident I went into. This was a programmer. I was teaching a class in Europe, and the programmer came to me, and we were talking about some code, something like this. The code was something like process shapes, and it was taking some input or whatever that was, and the developer had shapes is equal to get shapes, for example. Then we had transform shapes, which was transforming the given shapes, if you will. And then finally, the developer had display shapes or something like that, where we had a shapes, if you will, to display the shapes. And the developer looked at that code and said, hey, that violates a single responsibility principle. And I was confused. I said, my goodness, why do you say that violates a single responsibility principle? And the developer said, because it does 3 things instead of 1 thing. And I thought about it and didn't have a good answer. And I said to myself, if that is the only way we're going to define this, I don't think I can ever write code that doesn't violate the single responsibility principle. So I was quite annoyed by it. And it took me a while to figure out what was really wrong with it. But we'll come back and talk about it in just a few minutes. But really, going back to this question, let's take a detour and come back and explore a little bit further, and also address the comment from Artem as well along the way. So my first question to you, and I would like to receive, please type yes or no to the following question, right? So here's a question for you, and please type yes or no into the chat for the following question. So my question is, do you think writing a long function is a good idea? So what do you think? Do you think writing a long function is a good idea? And when I say long, think of a function that keeps on going, running, maybe tens of thousands of lines of code. So what is your thought? Do you think writing a long function is a good idea? And you can type yes if you think it's a good idea. You can type no if you think it's I won't take this answer if it depends. I already said tens of thousands of lines already. So I see a no happening there. Any other? Hell no. I like that response. Hell no. And I see a no as well. So we are seeing a few no's. We saw 3 no's so far. The others are either shy or they are disconnected and they left their cat to watch the video. You can train your cat to click on the no button as well. Another no I see. Any other responses? I'm going to wait a little to see if there are more people responding. Well, sometimes SK says, well, tens of thousands of lines is sometimes. I would like to know, when would you accept a 300,000 lines of long function or 30,000 lines of long function? When would you accept it? I'm curious. I'm not disputing with you. I would like to know when would be a yes for that situation. Well, mostly no, I see. So there are a few people. I've not gotten as many responses as I hoped to, but I see no mostly, and a few sometimes, and a few yes. Okay, so let's move on, switch to a next question. My next question to you is, have you seen long functions at work? So in your own code base, among your developers, have you seen long functions at work? Are all the functions relatively small? Haven't seen a case when such function cannot be split into parts. Yeah, we often may find a reason to split the function into smaller parts. So sometimes maybe what else? Have you seen long functions at work? Let's see, there are 2 responses so far. Maybe others are still either thinking or looking at their code and have not gotten out of the code. Maybe somebody is still counting the number of lines on their source project, or they are simply kind of shy and they don't want to respond. Scariest was 20 complex parameters to functions. Yeah, that could be really scary. I totally agree with that. I've seen and written some functions too. That's pure courage, Andrew. I appreciate that courage. And Oscar says, yes, we have seen that. So we have, this is a cognitive dissonance, right? And some of them made by myself. Mike says, yeah, again, that's a courage to really be able to say it. We all have written code of various degree of, beauty and beast in them. But, this is a cognitive dissonance, isn't it? So on one hand, we say we shouldn't write long functions. On the other hand, we see them. But the question is, why? And as it turns out, the question we may ask is, and you hinted to this already, how long is long, right? So if I were to say, 20,000 lines, is it really long? And we would say, yeah, 20,000 is long. What about 1,000? Maybe that is still long. What about 100? And we say, 100 may not be long. Maybe it's not long for Java. Maybe it's really long for maybe Ruby and Python or Clojure and so on. But on the other hand, how do you say it's really long? Well, as it turns out, here is a way to really ask the question. So imagine a friend of yours, a colleague of yours, who writes the long functions, right? So a colleague, a co-worker who writes long functions. And you have told this person many, many times, don't write long functions, but this person refuses to listen. And you have a suggestion for you. Go to work on Monday, but don't say a word. Your colleague, the one who writes long functions, looks at you and says, hey, how was your weekend? So how was your weekend? And you can answer in one of two ways, right? One way, it was great. Went to the park on Saturday, movie on Sunday, right? So that's one way you can answer your colleague. Or you can answer like this. At 7 a.m. Saturday, took the car out of the garage, right? Then you can say, turned to left, drove, 3 kilometers, turned right, drove 4 kilometers. And then you can say, turned left. And then I found that the road was closed. It was a detour, and I drove all the way for no good reason. I turned around and then came back 3 kilometers, took a left turn again, just rant away like this for as long as you can. At some point, your colleague in a lot of pain looks at you and says, excuse me, have you gone mad? They ask you the question. And you say, no, I thought I will tell you how my weekend was, like the way you write code, right? So you can tell them how you feel about the way they write the code. Well, obviously, you don't want to be that rude to your colleagues. That's not the way you would say things in real life. But the point is, this example, however fictitious, gives us an opportunity to think about how we communicate. So how do we actually communicate? We don't communicate with the left turns and the right turns and the left turns and the right turns. We communicate in knowledge chunks, right? So we communicate using knowledge chunks. That's what we do. So knowledge chunks is how we communicate. So when a colleague says, how was your weekend? Your answer is, I went to the park on Saturday, went to the movie on Sunday. Your colleague may say, oh, really? So how was your weekend? And the answer was, simply saying something like, went to the park on Saturday and movie on Sunday. So what does your colleague now say? This goes to the question that Artem asked earlier. What if you have a lot of these smaller functions? That's the answer here. And your colleague may say, which park did you go to is the question. Not park, but park. I keep modularizing code. I say park. Which park did you go to? You say, one by the main street. And your colleague says, I have heard about it, And then, of course, is it family friendly, right? So your colleague may ask, and your answer to that question is yes. It took the children, and they had a great time. And your colleague may say, what kind of activities are there? And your response may be about various different activities that are in the park. If you notice this approach, what did we do? So we can see the structure emerge, and this is called SLAP. So what is SLAP? SLAP stands for single level of abstraction principle. So in other words, each function, going back to Artem's question, each function deals with a single level of abstraction. You're not creating your goal. I want to emphasize the goal is not to create small functions. The goal is to create functions that focus on a single level of abstraction. So you're not really saying, I want to make the code arbitrarily small. That's not your goal. Your goal is to make the function focus on one level of abstraction. Hey, what was your weekend? How was your weekend? The answer to that question really is, what was your weekend? Went to the park on Saturday, went to the movie on Sunday. Notice the level of abstraction. The abstraction is your major activities during a weekend. Next to function, which park did you go to? The one by the main street, you're addressing the which. Well, what is it family friendly? Yes, it is. I took the children and spent the time there. What are your activities? You're going to list your activities. So every function. So you're not taking a long function and saying chop, 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 chop. Instead, you're saying, let's make that function top level function using what is called a compose method pattern, where a function is composed of the functions at one level of abstraction, and you move other levels of abstraction into smaller functions. That's basically what you're doing with the SLAP principle. So, like I mentioned earlier, more and more I am moving towards the single level of abstraction principle more than the single responsibility principle. And the word responsibility is rather confusing, but the level of detail or the level of abstraction seems to be a much better way to evaluate the quality of design. So I favor SLAP a lot more than SRP, which as I mentioned, is really about cohesion, but focusing on a single level of abstraction is a lot more rewarding as well in general. So moving on to the next three things I want to talk about. The next is called the open-closed principle. This was created by Bertrand Meyer, and the open-closed principle really focuses on extensibility when it comes to software. So it says a software module, and in this case, a module may be a class, a component, etc. So a software module must be open for extension, but closed for modification, it says. So a software module must be open for extension, but closed for modification. This sounds like magic, isn't it? How could you really have something open for extension, but you should be able to make it change and evolve without physically modifying the code? Well, the idea behind this is it's a far better to write a small piece of code than to really modify a lot of existing code. And that's what you're really focused on here, is to really reduce that. So the key here is abstraction and polymorphism are the key. And that's basically where this really comes down to. So to appreciate this, let's take a little example and play with it. Suppose I have a class called engine, and I don't have anything really specific in the engine right now. Then I have a class called car, and the class car, let's say, contains a private, let's say a year. It also contains a private engine as a parameter. Then I say a car takes a year and it takes an engine as an argument as well. So then I say this dot year is equal to the year, and I similarly say this dot engine is equal to engine as well. Now, of course, I also want to create a public, let's say, string toString function, and all I'm going to do within the toString function is return. Let's return the year plus, let's say, in this case, the engine as well, and we will return those two in here from this particular call. So given this particular code, let's go over and say car1 equal to new car, and let's say in this case 2021, and new engine as well, and we will output the car1. So not really a lot of code. You can see here is printed and the engine is being printed there as well. But then what I would like to do is to say a car2 equal to new car, but this is car1. Then I want to print out the car2 here. This code will not compile. Why won't it compile? Because there is no copy constructor in the case of Java. So the error, as you can see, it says constructor car in car cannot be applied to the given type. And it says you need an engine and an integer. You cannot pass a car to it. Well, what do I do to make this code to work? Now, if you look at this, you could say, hey, there is no copy constructor. So what is the solution? One solution may be write a clone function. And the answer to that question really is, but effective Java tells us not to write clone, but to write copy constructor. So why? This is something that really scared me. And the reason is, pardon me, when I read effective Java said, don't use clone, use a copy constructor. Let me rephrase it. What effective Java said is, don't use what we gave you, use what we did not give you in Java. It's like, go figure. Why did they say it? The reason they said that is, if a class contains final fields, then clone will not work if the value of the fields had to be different. Because if you write a clone function, you won't be able to assign to the to the final fields within a clone function. So that's why they said, don't use clone. Unfortunately, copy constructor is a bad idea when used alone. So why? Well, public car, other, and in this case, I'm going to say year equal to other dot year. Engine is equal to other dot engine is definitely not what you wanted, because notice the engines are the same. That's called a collision, not cloning or copying. So what I would like to do here in the copy constructor is to say new engine, and I'll say other dot engine, and I will make a copy using the other class's copy constructor. Now, for this to work, if the compiler will complain that new engine copy constructor won't work. So what am I going to do? I'm going to say public engine, and I'll say other, and that doesn't do anything. Now the compiler says, I cannot create a new engine other. Why is that? Well, in this case, it's complaining cannot find the symbol new engine other dot engine. Well, that's because, well, actually, I'm kind of surprised why that error came about. So it's complaining over here. I said new engine other dot engine. Oh, engine, not engineer. So engine, pardon me. So compile the code, and notice now the error is the other constructor, which took an integer and engine, has a problem because the engine doesn't have a regular no argument constructor. So to fix that, I'm going to write a no argument constructor, and the compiler is happy right now. Notice the engines are different in the output. Unfortunately, this code is broken. How so? Well, a few weeks from now, if I create a class called Turbo Engine, which extends from engine, and in here now, I'm going to write the copy constructor and a regular constructor. So here is a turbo engine, and a turbo engine. And all I'm going to do is simply say super other and pass it to the base class. Then in this case, if I were to come in here into the code and said over here, this is a turbo engine, unfortunately notice, while the first car has a turbo engine, the second only has an engine, which is not what we really wanted. So what do I do to fix it? Well, one way to fix it is to go to the copy constructor, and in the copy constructor, I can say this was a tight coupling because you're saying new engine to create an engine. Instead, I say if other.engine is an instance of, in this case, instance of turbo engine. Otherwise else, what am I going to do? If it's not a turbo engine, I'm going to assign it to a engine, if you will. Otherwise, what are we going to do? Otherwise, I say the engine is equal to new turbo engine, and this is going to become a turbo engine of other.engine. So we can write the code like so. But if you look at this code, what do you think of this code? I would say it's job security, right? Because it's a job security because every time you extend your code, you got to keep changing it. But that's a job you're going to start hating very quickly, if you will, because this is something becomes that mundane to repeatedly keep up with the code. So what's the answer? Well, I hate to say that I was wrong to say use clone before, and effective Java was also wrong to say use copy constructor, right? Use copy constructor. Oop, I don't know how to type today. So use copy constructor instead of clone. So both are wrong. I was wrong because I told people use clone, and effective Java taught me the lesson. You cannot use clone because if there are final fields, it's broken. Effective Java was also wrong because they asked us to use a copy constructor. But as you can see here, a copy constructor leads to extensibility problem. So what is the answer to that question? The answer is to use a mixed approach. So what I'm going to do is to make the car's copy constructor in here protected, and likewise to make the engine's copy constructor and turbo engine's copy constructor protected. So I made those two things protected, as you can see. Then in the car's car, I'm going to write a protected clone function. And the clone function of the car, what does it do? It simply says return new car this, and turns around and calls the car's copy constructor, which is protected. Then in the car's copy constructor, I set the year up. Then I say engine is equal to other dot engine, and I say in this case dot clone, and call the clone method on the engine. Now, what does the clone method of the engine do? The clone method of the engine says, so the clone method of engine says public engine clone. And what does the clone method do? The clone method simply says return new engine this, and likewise the clone method of the turbo engine says return new turbo engine of this. So we did a double dispatching approach. So we don't call the copy constructor directly. We made it protected. We from the outside call the clone method. So that should be public, obviously. So we made the copy constructor protected. We don't call it from the outside. We call the clone method, which turns around and calls the copy constructor, which in turn calls the clone method of the other object, which in turn turns around and calls the copy constructor, which is protected. So a hybrid approach. So I was wrong. In fact, Java was wrong. A hybrid approach works the best in terms of keeping code extensible. So essentially, in this case, if you notice, I can go back to this code now, and I can say in here, this is going to be car1.clone, and I'm asking it to perform the clone operation. And that creates me a turbo engine. What's the benefit? The benefit is tomorrow, if I say class, let's say in this case, a piston engine, and if extends from, let's say, an engine itself, and of course, in this case, I'm going to implement these, 5 functions, if you will, right? Or 3 functions rather. So what am I going to do in here? I'm going to say this is a piston engine. So let's say piston engine and return a piston engine. And here is the return new piston engine. Now, the beauty of this approach is if I go to the code right here and change this to from a turbo engine to a piston engine, I don't have to change any code for it to work correctly. So the open close principle says you want to really make the code extensible, but not by changing the code continuously, but by really making it easier to accommodate the change of extensibility without actually modifying the code. So we want to really strive to maintain that balance between abstraction and polymorphism to really gain that extensibility. The next principle here is called the Liskov substitution principle. And this really talks about, in all, about inheritance. And essentially, should we use inheritance or should we use delegation is the question. So should we use inheritance or should we use delegation? So I'm going to draw out one observation I normally use. If an object of A wants to use an object of B, then use delegation. If an object of A should be used where an object of B is used, then use inheritance. So essentially, the words I want to think about is to use versus to be used as or in place of. So ask the question, do you want to use something or do you want to use it in place of something else? So in other words, do not use inheritance for reuse. Use inheritance for substitutability. So this is where Barbara Liskov really comes in. So Barbara Liskov coined this Liskov substitution principle. And she says the user of a class should be able to use an object without knowing the difference if they are given an instance of base class or an instance of a derived class. So in other words, they should be able to interchange a base and a derived and use it interchangeably. So this really comes to substitutability. So the user of a base class should be able to use an object without knowing the difference if they are given an instance of a base class or an instance of a derived class. So why? Because if they have to know the difference, they would end up actually violating the Liskov substitution principle. So in this case, they say it's way better to use delegation rather than inheritance if your goal really is to reuse that object. Question from Artem is, I think it's most common when people first hear about dry and a good intention decide to move logic to an abstract class to reuse it. Well, actually, it is something we have to evaluate, because we need to make sure that it's actually a common logic that is needed. To answer that question, Artem, that's where a beautiful thing that Ken Beck talks about. He calls it as triangulation. He calls it as triangulation. So what is triangulation? He talks about triangulation as you implement a piece of code and you duplicate it and you see if it works well in two abstraction. If it doesn't work well, then don't go any further. But if it works really well, now extract the common into the base. That's why he calls it a triangulation. It kind of like forms a triangle, if you will. So your code is here, you duplicated it, and now it's in two places, and then you draw them up into a common base by extracting the commonality, forming a triangle. So 1, 2, 3, forming a triangle. So you want to really wait until you really see that the two abstractions are necessary and the code is truly working the same when duplicated, and then extract it. So thanks for that comment or question, but we want to really postpone it to extract it out into the base class. But sometimes I also extract it not as an abstract base class to the point. Sometimes I extract it to a delegation as well. What is common? That's another thing we have to ask the question. Does it belong to the base, or does it belong to a common delegate maybe that we want to use? We have to evaluate that as well. So in a sense, in this case, Liskov's substitution principle says use inheritance for substitutability, not for reuse. So in general, I'm going to give you a couple of good examples and bad examples. Let's talk about the good examples. In Java, public function in the base, right? Function in the base can be overridden only by a public function in the derived, right? So that's a very first thing. Likewise, in the same tone, in Java, a protected function in the base can be overridden only by a public or a protected function in the derived. So you cannot make that private in either of the case. In the case of a public method, you cannot make it protected in the derived. Why? Well, that's why it's substitutability. If you were to withdraw the permission in the derived, you cannot substitute the derived where a base is expected, so they don't permit it. The next thing is, if a base function throws an exception E1 and E2, right? Throws exceptions, let's say E1 and E2, then a derived overriding function can throw only E1 and E2 and not a new checked exception, not thrown by the base method. So in other words, if a base is throwing some exception, you cannot suddenly decide to throw a new exception in your derived. Again, Liskov's substitution principle, they don't want a user of a class to have a surprise exception they did not know from the base. So a derived should conform to the base's expectations. The bad example, one I can give you here, is in the JDK class stack E extends vector of E. That's a bad idea. Why? Because a stack is supposed to follow LIFO, last in, first out. A vector, you can insert and remove elements anywhere you like. So you should never really have inheritance in this case. In fact, this is such a big common problem that we have IDEs that actually give you the capability to work through these problems. Let's take a look at one example to see how this actually could become a problem. So let's go over to a little example and take a look at this really to see how this works and how tools are actually helping quite a bit with these kinds of problems as well. So let's take a little example here and play with it. Let's say I want to create a little class here to work with it. So I'm going to say create me a new, let's say a sample class, we'll call it sample. And in here, I'm going to simply say in this particular class, what do I want to do? Let me say we have a class called base with a function, let's say void f1, it doesn't do anything, and a public int f2, which simply returns a 0, let's say for now. So we have two of these classes given here. Now I say class derived, and whether I like it or not, I had said extends base. Maybe I didn't really mean that. Well, if that's not what you wanted, you can then go to the derived and you can say refactor, and you can say replace inheritance with delegation. And you can click on refactor, and notice in this particular case, you can simply say, in this particular case, not quite what I expected in this case. We'll try this again. So let's go back and say refactor again. Let's say replace inheritance with delegation. Oh, I forgot to select the methods. And I say click on refactor. And notice right there, what did it do? It said, I have a base instance. I wrote the F1, which routes to the base. I wrote a F2, which routes to the base as well. So it's really where you are able to use this kind of facility to modify and use inheritance. Well, refactoring tools can provide you that kind of capabilities, right, to make your life really easy. But here is the problem. This is one of the reasons why I'm not a fan of IDE-driven development. The reason is there is a deficiency in the design. What was the problem? The code violated the Liskov substitution principle. But now we are violating the open-closed principle and the dry principle. So you could argue that tools can make it easier for us to do the right thing or to do the wrong thing as well. So in this case, the dry principle is violated. Why? Because we duplicated the effort on this code right there. Secondly, it's a violation of the open-closed principle. If I decide to change the signature of one of the functions right here, that's going to break it right here, as you can see. And I got to come back and change the signature of this as well, for example. So it's not a perfect solution by any stretch of imagination, as you can see. But wouldn't it be nice if we don't have to violate the dry principle and the open-close principle? Well, this is where I think languages can become smarter. Two examples of that is Groovy and Kotlin. Both Groovy and Kotlin give you the facility to do delegation. I'll give you a Groovy example right here. So this is an example from Groovy. So I say hello from Groovy. Let's make sure that part still works. This is Groovy code. So let's go ahead and fire it up and execute it. And that's a hello from Groovy, as you can see. But now I want to say class, let's say worker. So what does a class worker have? It contains a work function where the work function simply says, oh, I'm going to simply say, working, right? So we'll just say working. That should be enough. Let's say if that actually works. So define, let's say, Joe equal to new worker, and we will call Joe.work over here and see if it calls the working, and it did. But let's now create a class called manager. As you would expect, manager does absolutely nothing. Then I say Bob equal to new manager. Then I say Bob.work. That's an alien concept for a manager. going to complain that I don't know what a work method is. It failed. But this manager is pretty smart. Simply says delegate worker is equal to new worker right there. By delegating, notice the working method is called because the delegate is an annotation in the case of Groovy that will allow us to route the calls that are in the worker via the manager. So in a sense, this is really what it is doing is doing code generation behind the scene. And as a result, the code doesn't violate the open close principle, not the dry principle, not the Liskov substitution principle. You may have seen this before in Project Lombok, for example. Project Lombok was inspired by Groovy, and you can do the same thing in Java using Project Lombok, for example. So essentially, you could use tools to perform these kinds of operations. In the case of Kotlin, the delegation is built into the language, so you don't have to work so extra. So that becomes a lot easier to naturally use delegation without violating open close principle, without violating the dry principle, without violating the Liskov substitution principle. The last thing I'll point out here is the dependency inversion principle. So what does this dependency inversion principle says? It says a class should not depend on another concrete class. Instead, they both should depend on an interface. And this is why it is called a dependency inversion. So what does the word inversion mean in this context? So if you have a class, let's say a person, and the person, let's say, depends on a clock, but they really need an alarm. So in this case, you are saying, let's create an alarm as an interface. Let's go ahead and inherit from that particular interface a clock, right, like so. And once we inherit a clock from it, we will then say we have a person that's going to come in here. And what does this person do? This person says, hey, I am going to depend on that alarm over here. So it's a dependency inversion because rather than a person depending on a clock, the dependency going from left to right, you could say the dependency now goes in the opposite direction because the clock now depends on an alarm and the person now depends on the alarm. So the direction of the dependency rather than the dependency. So in other words, rather than the dependency going into the clock, it is now coming out of the clock. So that's why the inversion of the dependency. So why is this better? Well, a person is coupled to a clock, whereas here, a person may use a clock, may use a smartphone, may use other kinds of devices for alerting them when an event happens, as an alarm does. So it becomes more extensible. So dependency inversion principle says, don't depend on a concrete class, depend on an interface. We got to be very careful, though. We don't want to do this arbitrarily. We want to make sure that it actually makes sense to do this in a context. Otherwise, it becomes overly complex. So we talked about a few different principles. You probably have heard about these principles as solid principles. I'm not a big fan of the use the word solid in general. The S in solid is for single responsibility principle. O is for open close principle. L for Liskov substitution principle. The D is for dependency inversion principle. Hey, what in the world did happen to I? I stands for interface segregation principle, which really is another form of single responsibility principle. But we did not talk about the dry principle in the solid or the YAGNI principle in the solid. I think those two are also really important. So if you are into giving these acronyms, maybe you should say we dealt with what's called the die-sold principle, not the solid principle, right? And I don't think die-sold really, reads so well, but all we did here was not a solid principle, but a die-sold principle. That's what we just did. And I really care a lot about not just the, the single responsibility principle or the open closed or the Liskov or the dependency inversion principle. I care about the drive principle and the YAGNI principle as well. And so I really like to use them along the way. Well, the problem with the KISS principle is, again, I would attribute this to like the responsibility. A lot of us will agree we should make things simple, but very few of us know what the word simple really means. So it's one of those that's really overused, in my opinion, is everybody says, yeah, make it simple. But when we sit down to make things simple, we have no clue what that means. So that's where, just like the single responsibility principle, I've also decided to hate the KISS principle as well, because it really becomes one of those overused things. Yeah, keep it simple. Okay, dude, you keep saying it, keep it simple, but your code is complex. Why? Well, that's because we don't really relate to what that word simple means in our own context. So a lot of these things are nice in concept, in discussion, but applying it, we need a lot more concrete help in realizing them in general. That's where the real trick really is. So that's all I have. I hope that was useful to think about or to rethink about some of these principles a little bit deeper, and maybe to start applying them a lot more in our projects, and also to be able to help the teams apply those things as well. I would be delighted if you have any other questions or comments. If not, that's all I have. Hope, again, that was useful. Thank you.